Well, welcome back. In this segment, we're going to talk about relational operators and selection in Java. And let's go now and look at the relational operators. These probably are not unfamiliar to you. So there are 6 of them. And some people separate them into the inequalities and the equalities. So the greater than, less than, greater than or equal to, less than or equal to are the inequalities, and then equal to and not equal to. Notice that we are using 2 equal signs here. So we're going to distinguish between the assignment operator gets and the equality relationship operator, which is the 2 equal signs. And not equal to is the exclamation mark followed by a single equal sign, and there cannot be a space in between these. When there are 2 characters, those must be without a space in between. And all of these evaluate to a Boolean, and that's very specific in Java. If you say 10 is greater than 5, the answer is a Boolean, and it's not 1 or 0, it is true or false. And of course 10 is greater than 5 is always going to be true. The operand types of the relational operators must be compatible. That means one must be promotable to the other, so that you're comparing like data types. This is the same in all of Java. The operators must have like type operands, and if they're not like, but they are compatible, then one will be promoted to the other. So if you compare an int and a double, you will really be comparing 2 doubles after the implicit promotion. Okay, the selection statements in Java. And selection means that we're going to selectively execute some statements, and it will always be based on the truthness or the veracity of a Boolean expression. So there are 4 of them. The if, and then an if statement with an else clause, the switch statement, and then this strange looking thing, which is really an operator, and it's called the conditional operator, or some people call it the ternary operator. So let's look at the if statement first. So here's how we're going to write an if statement. If with parentheses and something that evaluates to a Boolean, for example, a relational expression using our new relational operators, and then inside of this, these selectively executed statements. Statement or statements. So in Java, we have these braces, and it's not your choice where the braces go. This is a convention in Java that the open brace goes on the end of a line, and the closed brace goes on a line by itself. So here's an if statement, and we're going to use the braces all the time, even if there's only one statement in here. And we'll look at that in the development environment in Eclipse. So here's an if statement with the optional else part. So if this evaluates to true, we're going in and executing this. If it evaluates to false, we're going into the else part and evaluating this. The else never has a condition with it. It's the false part of this condition. And I forgot to say the obvious thing up here. We selectively execute these statements if this is true. So if A is greater than B, execute these statements. So when it's true, we go into the body of the if statement. One more, and we're going to look at these. I'll just give you a brief demo of them in Eclipse so that you get used to typing them and seeing them execute. The switch statement is something that is probably the least used and the most complicated. So we've got 4 new keywords: switch, case, break, and default. You switch on something, whatever goes here must evaluate to an int or be promotable to an int. So a long can't go here, a float or a double can't go in here. And the first thing that happens is that we evaluate whatever is in here. It might be just a variable, or it might be an expression that we evaluate and it evaluates to an int. And then we look at all of the cases, and there may be as many cases as you want, and each case identifies a constant that we would jump to. So if this evaluates to 5, and there is a case with a constant 5 here, we would jump to that case and start executing lines of code. You only jump to one case, and if this evaluates to something that isn't in any of the cases, then we would jump to the default case. I think it's easier to just write a simple one of these and watch it happen, and then you'll start to get comfortable with it. The default case is optional. You don't need to have a default case in a switch, and we will execute one of those in the development environment. Let's look at now the conditional operator, or sometimes called the ternary operator. So this is all one expression in Java. We're going to have the first operand must evaluate to a Boolean, and then there's a question mark. So if that's true, then this whole expression evaluates to whatever the true part evaluates to. Darn it, go back. So if this evaluates to true, the whole expression evaluates to whatever the true part evaluates to, and if this is false, the whole expression evaluates to the false part. So it's kind of like a little tiny if-else statement where this is the true and this is the false part based on this condition. And it is kind of handy if you want to do a little tiny if-else statement. You only have one thing to do in the true part and the false part. So here's an example of it. If A is greater than B, read the question mark, A is greater than B, then here's the true part. The whole expression will evaluate to whatever's in C. And if this is false, the whole expression will evaluate to whatever is in whatever this evaluates to. And we'll look at one of those in the development environment as well. So let's just go into Eclipse and play a little bit with this, and I really encourage you to go and do that now with me and type along, because for whatever reason, when you type it, you understand it. When I type it and you watch, it's not as much gets in. I know you know what that means. Okay, I've made a new project just for playing with this, and I encourage you to go and do this so that you're comfortable with what the operators do, so that when you're actually solving a problem with them, your time is spent on the problem and not on guessing what each of the operators do. So let's just declare a Boolean variable result, and then say result gets 10 is greater than 4.5. Okay, so this statement looks like what you're used to with arithmetic expressions, but this is a relational expression. So this evaluates to true or false, and in fact it evaluates to true in this case, and that's what gets assigned to the variable result. And notice with this relational expression, I intentionally used mixed data types. So I have an int compared to a double. And Java can't do that. So it promotes the int to a double, and then this comparison is done in double. So the operators also have a data type. And that's true with all operators in Java, and that'll be important somewhere along the line. So greater than, less than, greater than or equal to, less than or equal to, and then the equalities, equal to and not equal to. Let's see how you feel about this one. Let's say result gets true is equal to true. Does that make sense to you? So in this case, we're comparing two Boolean values and using a relational equals operator. And that one will work. True is equal to true is true, And I could have used Boolean variables here, or expressions that evaluate to Booleans, and compared those results with the relational equals operator. But watch this one. True is greater than true, or a Boolean is greater than a Boolean, and this doesn't make sense and it won't compile. So the equality operators work for the equality operators work for fewer data types than the relational operators, or the inequalities. True is greater than true doesn't make any sense. True and false don't have a larger and a smaller evaluation. But equal to and not equal to do compile and do make sense for the data type Boolean. There's only one more thing that I want to talk about when we consider the relational operators. Suppose I said 0.66666 is equal to 2.0 divided by 3.0. Is that going to be true or false? Well, why don't we just output it? SYSO control space will save you some time typing system out print line. Let's output the result there. Do you want it to be true or false? Well, you might have wanted it to be true, but it isn't. It's false. When you compare using the equalities, you shouldn't be comparing floating point numbers. Floating point numbers are an approximation. So this one is more accurate than this number. So there are more 0.6s there. So it evaluates to those two values are not equal. Floating point numbers are an approximation, and if you use equal to and not equal to with floating point numbers, sometimes you'll get the answer you want and sometimes you won't. So you're advised not to use equal to and not equal to with floats or doubles. Okay, let's immediately then go and start playing with if statements. And let me show you one thing that is kind of a time saver in Eclipse. If you select a bunch of code and you want to keep it around for some reason, but you don't want it to be executed, you can comment it out just by selecting it all and then hit Control / and that will comment it out and uncomment it out. And now we can leave that there as comments, and we can play some more in this same thing and leave that there if we want to refer back to it. So we're going to write an if statement, and here's the general form. We have lowercase if, and then something that evaluates to a Boolean must go here. So I could write if 10 is greater than 5, then go in here and say execute these lines of code. Ten is greater than 5 is not too complicated. Okay, think about these braces. The open brace and the closed brace define the body of the if statement. And if you have only one line of code as the body of your if statement, then these braces don't do anything. So the rule is that the if statement controls one statement or one compound statement, where a compound statement is created by including the braces. In Java, you're advised to use the braces even if they don't do anything. And the dogs say hello. They know when the mail arrives. It's a very important event in the house. Okay, so use these braces, even if they don't do anything, that's the convention in Java, and that's not a style. And your placement of the open brace here on the end of the line is also a convention, and it is not your style. You don't get to pick things like that. The indentation also is not important to the machine, but it is important in Java convention. And if your indentation is not the way you want it to be, if you're typing along and you decide you need to fix it up, Eclipse will do that for you. So I'm going to right click in the code window and say source, and then choose format. And it will put things back the way the Java convention says that it should be. So there isn't any reason to work with poorly formatted code, because it really just takes a second. Source, format, and it will fix up your code for you. Okay, so you can have as many statements inside of there as you want, and we will only go in there and execute those lines of code if the condition evaluates to true. So if this condition evaluates to false, then we don't execute these lines of code at all, and that's what selective execution means. So this is our first selection construct. Now, an if statement excuse me, an if statement may or may not have an else clause, and the else part is considered to be the false part. So if this is a Boolean, it must be true or false. There's no in between. It must evaluate to one of those. And in the else part, this this block of code, or this compound statement, will execute when this condition is false. So I'm thinking that this is not complicated for anyone. When you have an if with an else, you must do either the true part or the false part. So if the condition evaluates to false, we're going to execute the false part. The rule is the same for the braces. On the else block, you include them there even if there's only one statement and they don't do anything. The reason that this convention was put in Java so that it would prevent a bug from coming in later on. So if someone else comes along and says, here's another statement, now does that declaration happen based on this condition? The indentation seems to indicate that it does, but the braces indicate that it doesn't. So keep cleaning up your indentation and you'll see this kind of an error. This line of code has nothing to do with the if-else statement at all, because the else doesn't have these braces. So that's the reason for the convention of using the braces all the time. And what a mess that was. Let's do a source, format, and fix up the indentation. I'm getting some warnings in here that Eclipse can tell that this is always going to be false, but usually we would be using variables here. So now we have something that Eclipse doesn't complain about, and this is more realistic if you want to compare whether two variables are, how two variables are related to each other using the relational operators. Okay, so what can you put inside of an if statement? You can put anything you want in there, any executable statements, including another if statement. So if a is equal to 10, then Okay, here's another reason why the braces are kind of important. If you use the braces all the time, then it's easy to identify which if does this else match. So this if statement, it might get confusing whether this else statement matches this if, or whether it matches this if, but with lots of braces making it explicit that that is an entire if statement by itself, and that is an if statement by itself, then the else just fairly obviously matches. And writing complicated selection structures without the braces just unnecessarily makes the code harder to read, and in Java that's taken very, very seriously in the conventions that are dictated to you. So do it that way and it will save time. Even if you say, well, I could have made it a few lines shorter if I didn't use these unnecessary braces, it would make the code harder to read. Okay, I'm going to comment this out, Control / so that we can keep it there, and we can also work on the switch statement. So I'm going to declare a variable called choice and put a 2 in it, and then I'm going to switch on that choice. Maybe the choice was entered from the console. So switch on choice, and a switch statement says we're going to jump to one of the cases. So here are some cases. Case 1, and put a break statement here. And then case 2, and put a break statement here. You can have as many cases as you want, and in fact, if you didn't have several cases, you probably shouldn't be using a switch. You should be using some if-else statements. So I'll just put 2 for purpose of demonstration, and I'll put a default case, which is optional, and a break statement. So in here, in each of the cases, we're going to put what do you want to do when this evaluates to 1 or 2 or neither of those. So I'm going to just put in something for purpose of demonstration. Whoops, I selected the whole thing. Okay, let's think about what we have now. Here's the execution, how this happens. So the first thing that happens is that we evaluate this expression. It's a very simple expression. It's just a variable in this case. And it evaluates to 2 because there's a 2 in it. And then we look at the cases and see if there is a case that is exactly that. And in this case there is, so we would jump to this case and start executing lines of code. Well, what's with these break statements? There isn't any way for the case to stop unless you put a break statement. So if choice was 1 and we jump to this case and start executing lines of code, if the break statement weren't there, we would then continue executing into the next case until we find a break statement. And that's a common bug, forgetting the break statement. So if you don't want a break statement there, sometimes you would want both of these cases to do the same thing. You are expected to put a comment that says there is no break here, to make it clear to whoever's reading your code later that you intentionally left that break statement out. but I'm going to leave it in and change this back to 2. And now I want us to watch the flow of control in the debugger. And I don't remember if we've done this before. So I'm going to set a breakpoint so that we can watch the execution of this. So go out here into the blue margin and double click, and you'll see a little blue dot, and that represents a breakpoint where you want to stop. So now when we run the program, let me just clear that output screen. When we want to watch the execution so that we can see what's going on, we're going to click on the little bug up here instead of the run button. And the first time you do this, it will say it's going to change the perspective in Eclipse, and you want to do that. You can click Remember My Decision if you want to. So it changed the organization of the windows. So now the code window is somewhat smaller, but we have these other things so that we can see what's going on. So now we have a blue arrow that points at the line of code that is next to be executed. And we have these new buttons up here, Step Into and Step Over. We're only going to use Step Over for now. So let's execute the one line of code that this is pointing at. And what happened, we went to the next line of code, but the other thing that happened is when we declared that variable and put a value in it, it now appears up here in our local variables. So the purpose of this is to show you everything that's happening as you execute the code one line at a time. And this is a debugger, and it's the way to find the bugs. So if something's going wrong, you need to get into the debugger very quickly. So now we're going to switch on choice, where choice evaluates to 2. And if we execute that switch statement, we jump here into case 2 because that's the case that it matched. And then we're going to execute that line of code. We see it come out on the console, and execute the break statement. Where will we go next? Well, the switch is over. So we jump all the way down to the bottom. Okay, when you're done with this, there's a couple of things you can do. Usually I use the resume key and just let the program finish running by itself. You also have this red square button, and that means just kill the whole thing. You're done seeing what you need to do. And you can always use that button to kill it, or you can just let the program finish naturally. And you might notice that it didn't go back to the way it used to look. So we're still in debug perspective, and if we don't want to be in debug perspective anymore, we want to go back to editing the code, go up here to the upper right and switch back to the Java perspective. And that takes us back to where we have the Package Explorer, our project, on the left, and our editing over here. Okay, let's go back and play with this switch statement a little bit more. This must be an int, an expression that evaluates to an int or can be promoted to an int. These must be constants, and they must be unique. So this can't be a variable. Even a variable int will not compile here, and they must be different from each other, and the compiler can tell that. So if we had two case 1s, where would we jump to? And that won't compile ever. So we're going to say, there, we have different cases. So they must be unique, the cases must be unique and constant. This is a colon, not a semicolon. And that's fairly unusual in Java that we would use a colon for anything. Okay, what else can we do, or what do you commonly see done with a switch statement? Sometimes you might want to use a character. And the phone rings. Okay, so I'm going to think about what other things we might want this switch statement to be able to do. You can promote a char to an int, and sometimes people will switch on something that is promotable to an int, and then you can put in here literal character constants. So this is an int constant after the promotion. It doesn't look like an int constant, it looks like a char constant. But a case in Java must be an int constant. So now we're switching on the letter A, and we have the letter A here. And this case has an int in it, the 2. This is a bad idea to mix these cases. I mean, to mix character constants and integer constants, because you might not know that you're going to have a duplicate sometime. So the Unicode value for the constant character A is 65. And that means that these two are duplicate cases now. But it's possible that you would want to use letters as your case values. Whoops, there's a common bug, putting a semicolon there instead of a colon. Okay, so what do we have now? We have case A and B. So if this is an A or a B, we're going to jump in here and do this. So if you have several things and you want to do the same block of code, if any of those occurs, then you can stack up some case statements. Okay, I can't think of anything else in the switch statement. Well, just one more thing. The default case, which is optional, doesn't have to go at the bottom. Almost always people would put it at the bottom, but it would work just as well here at the top. Because remember the order of execution. We evaluate this, then look at all of the cases one time and see which one we should jump to. If this is none of the cases, then we would jump to the default label and start executing code there. That's very unusual that you would see the default at the top, but I always show people that to make sure that you understand how this is happening. So let's put that back down there at the bottom. Okay, and our messages don't make sense anymore for switching on letter, but that's okay. You know what's going on. So to understand this best is to set a breakpoint and walk through it in the debugger so you can see exactly which line of code executes. It can't hide anything from you. And we're going to use the debugger and encourage you to use the debugger more and more as we go along. And I think we have only one thing left in here to demonstrate, and that's the conditional operator. Remember that thing that has the question mark and the colon in both of it. And these appear only as a pair. You never use one of them without the other. So let's say int a, and we'll say a gets the result of evaluating this expression. 12 is greater than 5, question mark. Then put 23, else put 55. So what will go in A? This evaluates to true, that's pretty obvious. So the true part will go into A. And nothing happens with the false part. So it's the same as a little if-else statement. So what we're looking for is, what does this whole expression evaluate to? It either evaluates to what's in here or what's in here. Let's output the result of one of these conditional expressions. If I say that 13 is greater than 5, I type 23, it doesn't matter. Let's output 9, else let's output 34.67. And what will be output? Okay, a question mark goes there. That's better. We're going to output the result of evaluating this whole thing. So this is true. It looks like we're going to output 9, right? But we won't. Java will only work on like data types. So we have an int here and a double here. So what will be output? 9.0. So what we had to do was promote the int to a double. So in the ternary operator, which means it has 3 operands, the first operand must evaluate to a Boolean. You don't have any choice there. But the second and third operand can be any compatible data types. So int and double are okay because this int can be promoted to a double. You might have used strings in here. So I could say hello if I could spell it, and goodbye here. And now this compiles because we have 2 compatible things as the second and third operand in the conditional operator. And I sure hope that if we run this it will print out hello, and it does because this evaluates to true. If that had evaluated to false, then we would have printed out the false part. Okay, so that is the ternary operator. It's not all that useful. It just comes in handy once in a while if you have a little tiny if-else that you need to express. And just a brief summary to end this one. We have been looking at the relational operators in Java. There are the 6 of them, 4 relational and 2 equality operators. There aren't going to be any more. That's it for the whole language ever. And the selection constructs. So the flow of control constructs using selection. And there are only 3 of them in Java. Well, there are 3 of them in all structured languages: sequence, selection, and repetition. Sequence is really simple. The lines of code execute in sequence from top to bottom. Almost too simple to be considered a control construct. Selection is the next one, where you selectively execute some lines of code. And repetition, which is coming up, where we make a loop and repeatedly execute some lines of code. So for selection statements, it's considered that Java has 4 of them. So the if statement without an else clause, and then the if-else statement, the switch statement that we looked at with the cases inside, and then the ternary operator, which is like a little tiny if-else. I want to remind you and encourage you to use the braces even when they don't do anything. The general rule in Java is don't write code that doesn't do anything, including parentheses that don't actually change anything. And this is one exception to that rule. You do use the braces even though they don't do anything in the if statements. Okay, so that's it for this part, and I will see you in the next segment.